Okay, welcome to my YouTube channel, Physics Matters. Today I would like to cover a very important subject, which is called Superposition Principle. And why it is important? Because we will see, not only in this video, but also in later videos, that it occurs on many different places where we even don't expect it sometimes. And before we explain it with the help of examples, I would like to write down a simple definition. So what it actually means is that we have multiple influences on a system. Yeah, then we can calculate the resulting influence as a sum of all individual influences. And the best idea is to take a look at an example. And this could be, for example, an airplane in the sky. So we have here our airplane. Moving, for example, in positive direction, yeah, with the speed v1. And then we can, of course, have an additional wind speed blowing, or the wind can blow from any direction, for example, from the lower left to the upper right corner. So we have another vector v2, which pushes the airplane into another direction. And the pilot has to actually find some possibilities to mitigate this. And now we will actually try to quantify that a little bit further. And in order to do this, I would like to start with a special case. And this special case could be that the vector v1 that we have to add up to the vector v2 is exactly parallel to v2. Yeah, because then what it means is that we have here a vector v1 and we have another vector v2, and of course we have to parallelly shift it to v1 in order to add it up. So at the end we have here our vector v1 and here we have our vector v2. And our resulting vector that we get is just the sum of these two. Let's call it v3. And then we can already see immediately that instead of adding up v1 plus v2 in the vector form, we can just simply add up the absolute values of v1 and v2. So we can write v3 equals the speed v3 equals the speed v1 plus the speed v2. And this makes the life a little bit easier. So again, I want to discuss this with the help of a simple example. So let's suppose we have here an horizontal escalator. And we have two people standing on this escalator. One is person A, let's call her Anna, and one is person B, so we call him Bob. And this escalator moves in horizontal direction, in positive x direction, with a certain speed. Let's suppose it is simply given as 3 meters per second. Let's call this speed v3 because we also have to define the speeds v1 and v2 for Bob and Anna. So now we can here define for Anna the speed v1 in positive x direction, which could be, for example, 2 meters per second. And Bob moves into the other direction. And here we can say that the speed v2 of Bob should be identical to the speed of Anna, but in negative x direction. So we can say here for v2 is minus 2 meters per second. Yeah, this is important, that although we are taking only absolute values into account, we still have to take the plus and minus sign for positive and negative x direction. Okay, now we want to actually calculate the speed of Anna and Bob for an observer that looks from the outside into the system. So we can do the following. We can calculate the speed of Anna as VA, let's call it VA, equals V3, the speed of the escalator, plus the speed of Anna in her own system. So V3 plus V1, which means 3 meter per second plus 2 meter per second, and this would result in a speed of 5 meter per second. Yeah, so an observer sees her moving with 5 meter per second in positive x direction. And now we take a look at the speed of Bob, and let's call this VB, and here we have to write V3 and then plus V2. Yeah, but as we said before, V2 is actually minus 2 meter per second. So we can write here 3 meter per second minus 2 meter per second, and this results in a total speed of 1 meter per second. So Bob still moves in positive x direction, but with a slower speed than Anna from an outside observer. So from the point of Anna, it looks like that she's actually approaching Bob with a certain speed, and this speed we can calculate now. So we can calculate the difference between these two speeds, delta V, which would be in this case VA, the speed of Anna, minus the speed of Bob, and this would be 5 meter per second minus 1 meter per second equals 4 meter per second. Yeah, so for Anna, it will look like that she's actually approaching Bob with a speed of 4 meter per second. And if we then also define an initial distance between these two, let's say that this was, for example, 5 meter, then we can also calculate the time it needs to reach Bob. So in this case, it would be t equals, and then we remember from our introduction of speed and velocity that if we want to calculate the time, we have to calculate distance over speed, in this case the speed difference, and this leads to 5 meter divided by 4 meter per second, and this gives in total a value of 1.25 seconds. Yeah? So after 1.25 seconds, Anna actually reaches Bob. However, this is only, as I said, for a special case that both vectors are parallel. Yeah? In general, this is not the case, and vectors can have any directions. So let's suppose we have here a vector v1, and we have here a vector v2 pointing in to another direction, and also in general having a different length. Then we have to again parallelly shift v2 to v1, and then we can now draw our vector v2 in this way, and the resulting vector, let's use this color. The resulting vector v3 is then the sum of v1 and v2. So we can write v3 equals v1 plus v2. And yeah, then if we then want to calculate the absolute value of v3, which means the speed, we first have to add both vectors up, then calculate the absolute value of the sum of these two vectors, and this is the absolute value of our speed v3. So we can only write here v3, the speed is actually the length of v1 plus v2. And of course, in general, we can also have much more vectors. We can have vector v1 to v1, v2, v3, and so on. So then if this is the case, if we have actually multiple vectors, let's suppose v1, v2, v3, and so on up to vn, yeah, then the superposition principle says that the resulting vector vres is equal to the sum of all these individual vectors vi starting from 1 to n. And this is actually the main message of the superposition principle. So the content is that much important that I would like to highlight this. Yeah, so in the future we will use this expression many times. So again, I would like to make a short example. So let's suppose we have here a river with a boat, and this boat actually moves in positive y direction. Yeah, we can also, it is always very beneficial that we define a coordinate system. So this would be x and this would be y. So the boat moves in positive y direction with a certain velocity, let's call it vb, and the river by itself flows in positive x direction with the speed vr. And of course we can also define these speeds just to have some values. So let's suppose the river flows with 2 meters per second and 0 in y direction, and the boat vb moves in positive y direction with a speed of, let's suppose, 5 meters per second. Yeah, and then if we want to calculate the resulting speed of that boat, because now it is clear the boat will not reach here exactly perpendicular to the other side of the river, but it actually will be it will result in a downforce that actually makes shifts the boat a little bit further into positive x direction. And yeah, and this of course is also, this distance we can also quantify. Of course, we will do this in a few seconds, but just because of the fact that we have to add up both vectors individually in order to get the resulting vector of the boat. So we will do this by writing down the resulting vector vres equals vb, the boat vector, plus the vector of the river, and this gives in total 2 meters per second. And here we have in y direction 5 meters per second. Yeah, so this is the total vector, the resulting vector. So what we can also do now, we can calculate the downforce of the boat. Yeah, so in order to do that, we should first maybe define the distance of that river, which could be 50 meters, just to make it easy for calculations. And then, because of the superposition principle, we can actually treat the movement in y direction independent from the movement in x direction. So we can then calculate first the time that the boat needs to reach from one side to the other side, which would be given as, and again we have to write now distance over speed, which is in this case the speed of the boat. And if we insert our values, 50 meters divided by 5 meters per second, then we get as a resulting time 10 seconds. Yeah, which the boat needs to cross the river. And then in the next step, we can calculate the downforce. In this case, we called it S. And this would be equal to the speed VR of the river multiplied with this time t. So we can write now here 2 meters per second times 10 seconds. And this would result in a value of 20 meters. Yeah? So the boat covers a distance of 50 meters, but at the same time, it also covers 20 meters in x direction. Yeah, and this is everything what I want to explain today regarding the superposition principle. I hope that you learned something new and you enjoyed it. So I want to thank you also very much for your attention, and hopefully see you soon for a new video.